Lesson 69, Simplifying Complex Expressions. I am beginning the lesson. So first we're going to start with, first I'm going to show you the Venn diagram from your homework and how it needed to be drawn, the ones I graded yesterday. So complex numbers are bigger than any of the other two. Real numbers and imaginary numbers are two separate, I don't know how to spell imaginary, I don't think that's right. Okay, they're two separate sets. Imagine. No, it's right there. There's an N.
What about the Y? I don't see it.
I don't know. It's over there. Okay. Anyway, and both real and imaginary are also complex. So complex is the biggest. So to graph a complex number.
Complex. It's like you're saying flax.
I know, huh? We all have plaque. Okay, so what we normally would call the x-axis is called the real axis, and the one we would normally I don't even know. Y-axis would be the imaginary part. So this is called the complex plane. And each of these are I. So you have 1i, 2i, 3i, etc. Okay? And this is 1, 2, 3. So to graph 3 plus 2i, you just go over 3 and up 2. If you wanted to do 3 minus 2i, you'd go over 3 and down 2. So it's to me, super easy to graph that. If you see a plus bi in these symbols, that is called the absolute value of the complex number. To find the absolute value, you take the square root of a squared plus b squared, just like you would if you were trying to find the diagonal length. So remember, this is your 3, 2. This length would be the square root of 3 squared plus 2 squared. That's the absolute value. Just how far away from 0 is that number. Okay. So I equals the square root of -1. I squared will be the square root of -1 times square root of -1, which equals -1. I feel like we already wrote this down a minute ago. I squared times I, so that's -I. It's just a reminder, I guess. I to the 4th is I squared times I squared, which is a positive 1. The exponents on I is the remainder when dividing by 4. So any exponent, if your remainder is 0, 1, 2, or 3, then it will be equal to
Can you close that door while you're there?
1. If the remainder is 1, that means your I to the 1st power, which is I. If the remainder is 2, then it's I squared, which again is -1. And if the remainder is 3, it will be equal to I cubed, which is negative I. So if the remainder is 0, it's going to be the same thing as I to the 4th power. So some examples. If we have I to the 256th power, we're going to divide 256 by 4, and we get 64, 0 remainder. So that means this equals 1. if you have 3i to the 11th power, we're going to take 11, divide it by 4, and we get 2, remainder 3. So we come up here, the remainder's 3. So that equals negative I. So we're going to have a negative 3i is what this one will be equal to. And then I to the 18th power, if we take 18 and divide it by 4, it goes in 4 times, but the remainder is 2. So I to the 18th is the same thing as I squared, which is negative 1. So I to the 18th would be negative 1. So all you have to do is divide by 4 and then look at the remainder. When we have a complex number in the denominator, we have to rationalize the denominator. So if you remember, in our denominators, we only want rational numbers, or integers actually. So I'm going to give you an example, and you do it just like you do with irrational numbers. You multiply by the conjugate. So if we have 10 divided by 2 plus I square root of 2. This is are you guys listening?
Yeah.
Okay. So I need to multiply by the conjugate, which would be 2 minus I square root of 2. 2 minus I square root of 2. So the numerator is pretty easy. We just write 10 and then 2 minus I root 2. To find the denominator, we need to use FOIL. So we'll have a 4 minus 2I root 2 plus 2I root 2. So that goes to 0, the middle term. And the last term is a negative I squared times square root of 2 squared. Square root of 2 squared is just 2, and I squared is negative 1. So I'm going to do 4 minus a negative 1. No, 2. Because 2 times negative 1, yeah. So 4 plus 2 is 6. Then I'm going to reduce, make that a 3 and that a 5. So my final answer will be 5 times 2 minus I root 2 all divided by 3. And if it says to write it in standard form, you would have to do 10/3 minus 5I root 2 divided by 3. So you have your number part and then your imaginary part. But this is fine for now. Here's another one. If I had 6 plus 21I all divided by 3I. Before I rationalize the denominator, I would divide by 3. Tan?
Since, okay, this is kind of a stupid epiphany.
No, it's
Okay, so like, when you have a square root, you can always take out 4 i's. There's always 4 i's in there. So you can always take out 2 i's, which makes it negative.
Uh-huh. It's true.
Right?
Yeah. I think. I kind of understand that, but not really.
Like the square root of 4 I to the 4th would be negative 2.
Okay, I'm going to discuss that with you in a
isn't
minute
that
because
why
I got to
it
finish
works?
this.
Isn't that why
Possibly.
it works?
I think so.
Plus
But
or
I'm not sure.
minus 2
Hang
is
on a
the
second.
square.
Just a minute. I got to ask you in a minute. Oh, maybe. Yes.
Doesn't that make sense?
I think so.
Sorry.
So, I know that I squared is a negative 1, but it would be nice if the denominator were a positive 1, so I'm going to multiply by negative I. Is that going to confuse anybody? So negative I squared is just equal to 1. So I'm going to have a 1 in the denominator. In the numerator, I'm going to have a negative 2I minus 7I squared. But I squared is a negative 1. So this becomes a plus 7. So I'll rearrange it and do 7 minus 2I. And that would be the answer for rationalizing the denominator on that one. Okay, we're gonna do some practice.